Hello, Aaron. Let's continue our experiment to save the life to observe the organ phosphate poisoning and saving. Okay. Just now we have observed the normal M and N signs, and we also take the blood. Later we want to observe the level of normal acetylcholinesterase. Okay. Let's continue our lab. The second step of this lab we use organ phosphate and then we observe the M and N signs again and then we will get the blood again. Okay. So the second step we will use organ phosphate. The organ phosphate is 2.5% dipteryx and the dipteryx is the most commonly used organ phosphate. It is one kind of pesticide and its rabbit, we use these doses. Each kilogram we give we give 6 milliliter. So just now we have known our rabbit 2 kilogram, so we give 12 milliliter dipteryx. The administration method is intraperitoneal injection. Intraperitoneal injection. After we inject the drugs, inject dipteryx, observe the toxic M and N symptoms. It may cost 5 to 15 minutes, and then you should record this M and N signs in the table. Just now in the first step, we have observed the normal M and N signs, includes the first one, activities, and then the second one is breath rate, and the third one we should know observe the pupil size. Number 4, salivary secretion. Number 5 is the urination and defecation. At last, it is the N signs, the muscular tension, and we should know because just now we inject dipteryx, so N signs and means the muscular tension increase, and the last symptom is the fasciculation. Okay, let's do the lab. Okay. At first, we give the organ phosphate. The drug is dipteryx. Chinese name is dibaicheng. We use 2.5% dipteryx and intraperitoneal injection. And near the middle line and the lower abdominal cavity, intraperitoneal inject dipteryx. This rabbit 2 kilogram, so we give 12 milliliter dipteryx. After we inject the dipteryx, and maybe cost 5 minutes to 10 minutes to 15 minutes. Most rabbits will have the M and N size will have the toxicity in 15 minutes. In 15 minutes, so 5 to 15 minutes later, let's observe the M and N signs. And just now we intraperitoneal inject the dipteryx, so M and N signs overdose. And then let's do the lab again. 5 minutes ago, we inject dipteryx. And now let's observe the pupil size again. And just now we also know in normal 7 to 8 milliliter, but now overdose dipteryx, so the pupil size smaller. And you should know in clinic, 2 kinds of drugs overdose induce pinpoint pupil meiosis. So the first symptoms of organ phosphate overdose is meiosis. Pupil size is smaller than before. So just now we observe and calculate the pupil size above the 4 to 3 milliliter, so smaller. And in clinic, just now I said only 2 kinds of drugs induce pinpoint pupil. One kind you should know the patients use organ-phosphate self-suicide overdose. And on the other hand, you also should know we studied analgesics. Yes, morphine overdose also induce pinpoint pupil. So in clinic, when the patients go to hospital, and you should observe their pupil size, and pinpoint pupil often occurs in these two patients. One is organ phosphate overdose. The other one, they are drug indicators. Okay. And the second symptom, we should observe. Oh, the pupil size is smaller than before, and the breathing rate. So let's calculate breathing rate is lower than normal. That's now 30 times each minute. And that's now we touch the rabbit. And only 20 times, so lower than normal. And the third symptom is because promote dipteryx organ phosphate, promote gland secretion. So the third symptom is this one. Okay. Okay, here. And then the muscular tension. Oh, fasciculation. Okay, fasciculation. So H is the N sign, and in fact, it is the last sign. That means H is the last sign. When you see the rabbit, the patient, paralysis, and the fasciculation, and it is the last sign, so means you must save the life immediately. If you don't know this, and the patients will die in several minutes, so very dangerous. The last symptoms. Okay, let's continue the lab. That's now the second step of this experiment. We administration dipteryx and then observe the symptoms, and we also observe the muscular tension increased, fasciculation, and has amyostasia. Okay. Before we save the life, so we should take the blood again. Get 0.02 milliliter. That means 20 ml blood after the toxic symptom is manifest by the same method as the previous into the tube 2. Okay, so let's take the blood. And we also need 0.02 milliliter blood, 20 ml. So in this line. Okay. And put this 20 ml blood into the second tube. And the other student, don't forget, use cotton. Okay. In the tube, have 1 milliliter distilled water, and then we add 20 ml blood into the tube, the second tube. And later we will use this blood to test the level of acetylcholinesterase. Okay, so we have 2 tubes. The second step. And the third step, that's now the lab, the rabbit fasciculation. So we have known it is the last sign. So we must to save the life. And before you save the life, so you should prepare the drugs to save the life. And we will use the special antidotes. Use of antidotes means 2 drugs. One is atropine, the other one is pimechloride. And we can divide into 2 groups. The first group, you give atropine, 0.1% atropine, and each kilogram we give 2 milliliter atropine. So our rabbit 2 kilo, and we give 4 milliliter atropine intravenous injection. Intravenous injection atropine and wait 3 minutes, and then you give 2.5% palm chloride. Each kilogram we give 4 milliliter palm chloride. That means we will give 8 milliliter palm chloride, also intravenous injection. In the second group, you are different. At first you give palm chloride, and then you give atropine at the same dosage. So the second group, you inject palm chloride, each kilogram 4 milliliter, also use intravenous injection. 3 minutes later, you give atropine, each kilogram 2 milliliter, intravenous injection. Maybe you're confused why we use the same drug but different turn, because you should know. For example, the first group, you inject atropine. That means after you inject atropine and the enzyme be slowed by atropine, but the rabbit still paralysis, and then we use palm chloride to observe to slow the paralysis. And the second group, you give palm chloride, so that means your rabbit, the paralysis and the fasciculation disappear, but the enzyme still occurs. So we give atropine, and then enzymes disappear. So different things and slow different sign and symptoms. But just now, in the beginning of this lab, we have known the first choice agent is atropine. So, in fact, later you save the life means the first group, your therapeutic effects better than the second group. That means the mobility of the second group higher than the first group. And after we use the drugs, we use the special antidotes, atropine and palm chloride, and you can save the life. Then observe and record the change of the toxic M and N signs again. After that, get blood 0.02 milliliter into the third tube, and later we use this blood to test the level of esterase, isotretinoin esterase, and we should know we use the palm chloride means H is the isotretinoin esterase reactivator, means the level of this enzyme is increased. Okay, so let's do the lab. Let's do the lab. Okay, let's do the lab. And the rabbit use organophosphates overdose. So let's give the drugs. And the first drug, the first choice agent is the atropine. Here is the atropine. So intravenous inject atropine. Each kilogram we give 2 milliliter. So the rabbit 2 kilogram we give 4 milliliter atropine. And the rabbit toxicity, poisoning, fasciculation, and intravenous inject the first choice antidote is atropine. So let's inject atropine. After you inject atropine, don't forget to observe the M and N signs. Yes, in fact, we have saved a life, but the pupil size larger than before. So maybe 12, 11 milliliter. And then dry mouth and the breathing rate is increased from 20 to 40 to 30 each minute. But no salariuria because still salariuria. Okay, we should wait a moment. And but the rabbit still face the muscular tension still higher than normal. So we wait 3 minutes and then we give the second drug to save the life. The drug is the palm chloride. So we use palm chloride. And in normal, we should put palm chloride into this brown bottle. Each kilo 4 milliliter. So we give 8 milliliter palm chloride. In clinic, palm chloride can be selected according to the patient's condition or other presences. The expected value of the current available palm chloride treatment of organ phosphate intoxication is now seriously reconsidered. Although palm chloride has been designed to reactivate the inhibited esterase by organ phosphate. Clinical experience have indicated that they are not always very effective as reactivators. Thus, now we intravenous inject palm chloride and the paralysis disappear. Have you seen? So that means we use two special antidotes. Atropine mainly slow the M signs and symptoms, and palm chloride mainly slow the N signs, paralysis. Okay. And after we inject both two drugs, let's observe the symptoms again. The pupil size larger than before, 12 millimeter, and the breathing rate is increased higher than just now. So maybe 40 times each minute, the muscular tension is normal. And no salariuria. Okay, no salariuria. Okay, it's alive. And just now we save our rabbit the life successful. And don't forget, after we save the life and get blood again the third time. Okay, let's get the blood the third time. Oh, it's the last time. And take the blood 0.02 milliliter. And we use the capillary peptide and add this 20 ml into the third tube. In the third tube, 1 milliliter distilled water and 20 ml blood. Okay, let's continue. Maybe in clinic, you should know we should use the first choice agent is atropine. And atropine, how to use atropine? The first one, repetition. So we only give one time atropine. If in clinic, the patient's heart rate isn't increased or the the no dry mouth, dry skin, and you should repeated use atropine again and again. Understand? It is the first choice agent. You should repeated use atropine. And the second principle, how to use atropine is 4 doses. And the third one, as early as possible, conceal the life. And then the fourth principle is combination. Atropine combination with isotonic esterase reactivator. Okay. Combination with PAM chloride. The therapeutic effect of detoxification, that's now in the lab, you should know. We use atropine. And mainly resolve emphasize. And the reactivator, no effect, PAM chloride, not effective for the intoxication of roger. Atropine should be simultaneously used. So I have explained the principles of how to use atropine. We follow with the principle is repetition, full dose as early as possible, and combination with other therapies. Okay. So we take we take the blood 3 times. The first time before we give organophosphates, and the second time we take the blood after we give organophosphates, and the third time we take the blood means that after we save the life. So we use these 3 times the blood to determine the activity of isotylcholine esterase. Isotylcholine bound to add into water, and then under isotylcholine can convert into acetic acid. And because acetic acid, it is acid solution, so in accord with the pH value, low pH value means the yellow. And then in accord with the pH value increased, the color higher and darker than before. So low pH yellow, and then yellow green. The dark is this one, green. The higher activity of acetylcholine esterase, the nearer to yellow. The lower activity of acetylcholine esterase, the nearer to green to blue. So from this one, we know as acetylcholine esterase in high activity, light color, yellow, and acetylcholine esterase low activity, dark color, green or blue. Okay, so from this, let's continue our experiment. We have 3 tubes. The first, second, and third tube. In them, we have added 1 milliliter distilled water in each tube, and we also add 20 ml blood. The first tube, we add 20 ml blood in normal, and then after we inject organphosphate dipteryx 15 minutes, we take the blood again 20 ml and add into the second tube. And the third one is after we inject atropine and PAM chloride, after we save the life, we take the blood the third time. Also 0.02 milliliter blood into the third tube. And then add 0.25% isotylcholine, each tube 0.5 milliliter. And put these 3 tubes in in 37 to 38 centigrade and homothermia. At last, add 1.5 milliliter BTB, and will have different color. If the color tune is not obvious, keep the tubes into the water bath for 10 minutes after adding BTB. Okay, let's do the last step. We have 3 tubes. The first tube is normal. The second tube after use organphosphate. The third tube is after saved life. We give the atropine and the PEM chloride. And we add 0.5 milliliter isotaclin into each tube. 0.5 milliliter isotaclin into the second tube. 0.5 milliliter isotaclin into the third tube too. Okay. And we can put these 3 tubes into the water and wait 10 minutes. And then, at last, we give this BTB, colorimetric solution. 1.5 milliliter in each tube, BTB. And we'll have different colors. Do you remember just now we explained the activity of isotaclin esterase? High activity, yellow solution or light solution, light color. And then lower activity, dark color. This is the first one, the second one, and the third one. Don't change the tints. Okay. This is the first, second, and the third one. The first one, yellow, so means the high activity of isotaclin esterase. The second tube, dark, maybe it feels green or dark yellow, means the lower activity. And between them is the last tube, the third tube, means we use PEM chloride. The isotaclin esterase activity is increased, so higher than organphosphate, but still lower than normal. Okay. Just now we have do the lab. We use and we know the different colors of different tubes, and we can, in accord with the color, can know the activity of isotaclin esterase. It means the yellow and high activity. Dark means the low activity. Between them, because we use PEM chloride, we use isotaclin esterase reactivator. Okay, this class, in this lab, we have done the very easy lab, but very useful, because in clinic, each year have 2 million patients. They use organphosphate self-suicide, and in them, the death rate about 60%. So as a doctor, you should know how to save the life. And let's summarize. In normal, and we observe the M and N size, and then we take the normal blood. And the second step, we inject organphosphate dipterex each kilo 0.6 milliliter intraperitoneal injection. And then in 5 to 15 minutes, we observe the toxicity M and N size. And we also take the blood again. And we use 2 drugs to save the life. One is atropine, the other one is PEM chloride. After we saved the life successful, and we observe the M and N sign again, and we also take the blood in the third time to observe the activity of isotaclin. Okay, let's summarize. The signs of organphosphate, and we should know, include M and N signs. Typical symptoms include diarrhea, urination, meiosis, bronchial constriction, fasciculation, and convulsion. Also, salivation and sweating are very obvious. And we use two drugs to save the life. One is atropine, the other one is isoticline. And prevention of organ-phosphate intoxication is very important. In the treatment of acute organ-phosphate intoxication, simultaneous use of atropine, repeated use atropine, and use isoticline, a stress reactivator, is very effective. Okay, and we have two questions. The first question, yes, do you know how to save the life? And some poison mushrooms, and do you know how to save the lives? And try to design the treatment of blind for severe acute mushroom poisoning case. Do you remember which drug is the first choice? Yes, very good, atropine. And the second one, yes, try to design the treatment of blind for a severe acute. This flower is the Simsonweed flower overdose. Okay, we use which drug to save the life? Okay, class is over. See you next time.